title screen there.
Yep. Yeah. Can you guys see the screen?
Yes, we can.
All right. All right. Yeah. David and I are here to talk about high-speed interconnect building blocks for modular system architectures. We'll do a quick introduction here. My name is Chris Blackburn. I'm a technologist from TE Connectivity, and I'm on our system architecture team. And I'm located here in Seattle, Washington.
Hello and good morning. Is my audio coming through okay?
Sound good?
All right. So I'm David Herring. I'm also a technologist on our system architecture team at TE Connectivity, and I am located outside of Raleigh, North Carolina.
So we wanted to talk a little bit about system modularity. As architectures are becoming more specific to data workloads, agility and flexibility is absolutely key. And as we design systems in networking, compute, storage, and even AI and hardware acceleration, it's becoming increasingly important to consider modularity in these system designs. This creates technology independence where different components and subsystems can be on different development schedules. It enables reuse both of designs and components and subsystems, and also increases development schedules. All of these things in turn drive supply chain flexibility and cost efficiencies in the designs. Several of the device form factors that we see on the screen here right now are common standardized form factors for storage, hardware acceleration, and even networking. And several of these that we show on the screen have actually been brought to market by the OCP community, including the Open Accelerator module, the NIC 3.0, and of course, DCSCM, which is currently in progress. And one of the commonalities and things you'll see here, many of these devices leverage a common card edge connector interface. And you can see the four device form factors there highlighted in that pink all leverage the SFF TA1002 card edge interface. And you can see that there's various sizes and pin count configurations, and also connection configurations for these different applications. So with that, I'll pass it over to David, and he'll talk a little bit about how these device form factors are implemented in systems.
Thank you, Chris. So when we think about at the system level, we're able to take these devices, which are built around an ecosystem, and we can take those devices and make them compatible to our systems. And this can be done in a variety of ways. And there's a variety of reasons that might warrant, certain connection schemes. As we start on the right, we have PCI add-in cards, which are fairly common and have been around the industry for many years. And there's even an emerging variant of that that has a public specification, PEC-FF, that leverages the TA1002 interface. And from a system perspective and the volumetric envelope, these form factors have been designed around, and system developers know how to manage these. Whether it's a 1RU or a 2RU or 1OU or 2OU or other system height, there may be a need for riser card applications. And benefits of the riser cards can leverage this common interface, which has some performance benefit gains, and then help with those transitions to fit these devices in your system. The other form factors, such as an OCP NIC, is also able to leverage this, whether it's plugged direct into a straddle mount, right angle, or maybe even a vertical backplane, should the system warrant it. We have the new form factor defined in EDSFF. We have the E1.S, the E1.L, the E3 devices. And these form factors are emerging to develop their ecosystems as well. And not only limited to SSD type applications, but with some of the technologies that are coming, these form factors can now be leveraged to enable other technology intercepts. Perhaps some things enabled through CXL. And then when we have the common cable to board interface, with these standard card edge interfaces having the commonality of a cabled interface, that also opens up a variety of ways of implementation, whether it's continuing to do a cable to from a host board to a storage or other PCIe delivery backplane, or maybe even directly to the device itself in either of these form factors. So the card edge connector interface does enable those simpler design choices from a modularity and system design perspective. So you can have basically a Lego type of system that can be built together, stacked for the workload requirements. And based on that, there's some system modularities that do require some other type of interconnect options. And I'm gonna throw the baton back over to Chris to step on this a little bit.
Yeah, thanks, David. Yeah, so David talked a little bit about how card edge connectors can be leveraged to enable modularity in system designs. One of the important aspects of modularity is the blind mate ability and gathering of the connector interfaces. So as we have sub chassis or device form factors that need to be plugged in either in the faceplate or the whole chassis plugs into the rack per se. Blind mate connections are becoming more important here in this regard. So we talk a little bit about the float and gatherability, again, to take up some of those system tolerances such that when you plug these devices or chassis that the connectors are properly aligned and mated. But backplane cables and connectors also enable flexibility in system topologies. David briefly mentioned CXL, and one of the things that we see happening in the market today is the need for these highly connected clusters and even fabrics. So backplane connectors and cabling allow that breakout and these highly interconnected pools of devices. As we look at these two together, card edge connectors and backplane connectors, and enabling true modularity, one of the increased trends we see is the need for these hybrid cables. And I show a cable assembly here with SFF TA1002 on one end and a cable backplane, either header or receptacle on the other end. And these hybrid cables will allow us to connect devices that already have one of these connectors specified and or bring in the blind mate and gatherability aspect to one end of that system. So for example, launching from your CPU board or your host board to a panel mount connector in the back, this cable would allow you then for that whole chassis to be blind mated. And we show a few different configurations in the images here, whether it's a traditional backplane, cable backplane, orthogonal, or these hybrid cables like I talk about. And this is really interesting because these connectors enable a ton of different applications, also including some of the near chip connections or even to on package connections that we're beginning to talk about. So we talked a little bit about modularity here at the device level and now say the subsystem or system level. And we can take that same theme and push that beyond. And with that, I'll pass it back over to David to talk a little bit about how modularity can be extended beyond the system.
Thanks, Chris. So now that we've looked at the composability from the device and the system level, that same philosophy can also be applied at the rack level, especially now that we have these increased technologies from PCIe generations or Gen Z, other CXL, other types of communication transports and fabrics that can now enable disaggregation within the rack and some composability at that level. Whether it's your networking to compute and power and storage, we can also enable this from a power delivery perspective. Almost now like your rack can be thought of as your previous system, and you can really tailor this for the right workload, for the right space, and maybe even beyond. We haven't talked about how we can maybe apply something at the data center level where the rack is maybe the composable infrastructure. But maybe that's a little far out, but the theme can be applied at each level along the way. All right, thanks, Chris.
Yep, great. Yeah, so to kind of summarize and pull this all together, I think we talked a little bit about some of the benefits of modularity. And of course, this allows the community to go out and develop the ecosystem rapidly make technology innovations in their respective areas, and then be able to pull this all back together into a functioning system. You know, there's so many different aspects of system designs that we're all thinking about and are near and dear to our hearts. But one of the things that we'd like to push the community is, as you're designing systems, subsystems, devices in these respective sub-projects and sub-communities, you know, like the server or storage, networking, edge, et cetera, to really push system designers and engineers to think about leveraging common connector interfaces. As we start to use standard and common connector interfaces, we can really achieve that full system modularity. So with that, that's David and I's presentation here, and we can field any questions. Thank you.
If anyone has any questions in the audience, please hit the click to gain speaker access button and you can ask those questions live. I'm also looking at the screen and I do not see any comments or questions coming in through the chat or through the Etherpad yet.
So again,
Yes,
if there's no question, I can maybe open up some questions.
Go for it. You have about 2 minutes or so. Yeah.
You guys know, every time that we talk about modularity, people are concerned about cost adders. I'm sure you have studied that. Any comments that you can share with the rest of the team?
Yeah, I'll field that one. So one of the things, you know, with cost adders, we talk a little bit about component and design reuse and leveraging these common connector interfaces. You know, as an industry, if we can drive volumes higher on specific interfaces and reuse those across multiple platforms, we can all benefit from those economies of scale and drive the cost down of those interconnects as we increase volumes. So again, that really pushes the need for these shared interfaces. You know, you have EDSFF as a storage form factor, and you know, why not reuse a similar design for, say, an accelerator form factor when we have that connector ecosystem already developed?
Yeah, and just to add, I would say that, you know, there's the cost of the interconnect aspect and having that commonality and economies of scale, you know, certainly help. But then there's also the cost, you know, for the ecosystem form factors and the device vendors being able to know that they have a technology that a system implementer is going to be able to consume, but multiple system vendors can consume.
Very good. Thank you.
Okay, everyone, appreciate your time. Thank you, David and Chris. We are going to be taking a 10-minute break. Please do go into the lobby. We do have a meditation break set up by Facebook. And you just go back to the lobby and click into it, and you should be able to take a 10-minute breather per se. So thank you again, and we will meet back here at 10:10. Again, we got a lot of great presentations coming up after the break.
Awesome. Thanks,
Great.
everybody. Take
Thank
care.
you.
Thank
See y'all.
you.